Hello again. Another question here for the Impress Me task. This is Impress Me task 2, so I'll be expecting this one around if you're doing it in 2021, 2022, it'll be around the 10th of January. So Impress Me task 2, I'm not going to give you any tasks that you've not already covered the content for. The question is, explain how earthquakes and volcanoes occur at destructive plate boundaries. We could even add in tsunamis there, but I'm not going to overload you with things that you need to do. So the first thing to note is that here we've got just a quick diagram of how volcanoes and earthquakes occur at plate boundaries. And maybe I might mention a couple of other features that you will find at this type of plate boundary. Of course, we know that this is a destructive plate boundary, and another way of saying that is a convergent plate boundary. Just draw a line away from our destructive plate boundary here. If you wanted to mix up the vocabulary, converging means that something is going towards something else, so it's a converging or convergent plate boundary. Now we can draw our arrows for the direction of the movement of the plates, and down here in what I'm going to do as kind of some red here, that's going to be our mantle. And in the mantle we've got this movement in a kind of a circular motion of what are called convection currents. Convection currents move that way near the top, near the crust, and then eventually when the magma kind of sinks from the pressure that's felt at the top here, and it can no longer usually go any further, it's going to sink back down and move in the opposite direction. It's kind of like a wheel, so it's almost like this wheel is constantly moving in this direction, pushing the plate that way, and this happening over here as well. And the direction of the magma here that's rising is moving that way, and the direction of the magma that's sinking is moving this way. So we've got our two wheels pushing our plates in this direction. So our heavier plate, our oceanic plate, is over here. Some of you, a lot of you in your work in Impress Me Task 1 really did impress me, because you referred to the concept of oceanic plates and this concept of the term subduction, where a plate sinks beneath a lighter plate. So in this case, the plate that's covered with ocean is more heavy. It's gonna subduct when it meets this continental plate, and that line is actually called the Benioff line, which is something that you might want to refer to if you think you're worried about my spelling. I am generally worried about my spelling. If you would like to look up to see if I've spelled that correctly, please do feel free. So along the Benioff zone is where we're going to see this subduction occur, and when it gets close enough to the hot magma, that's going to melt it, and this melting is going to force magma up through the crust. Okay, so we've got this melted rock coming from over here. It's going to move through the crust, and I've just drawn my magma chamber already, but here it is. That's going to be put inside the Earth's crust, and that's what's going to feed our volcano and make it erupt. Okay, so got our sticky, viscous lava, and of course it's not going to move as far as a shield volcano's lava will. However, the other things that are created at the from this volcanic eruption, many of you mentioning the gas cloud, the ash cloud. Actually, not too many of you mentioning, I should say, that I've read so far, but maybe I'll see that in the next few that I read before finishing all of the feedback that I give you. Okay, now that's how the volcano is being created along the plate boundary, and the plate boundary is here because this is where the two plates are meeting, or you could say this is part of the boundary here. This zone is where we're going to experience a lot of deep focus earthquakes along the Benioff zone. Let's put EQs for earthquakes there. Some other things that we're going to find is that we've got a very, very deep area here where the two plates meet, and that's called a deep ocean trench. Put that here. So a deep ocean trench. And also, from the pressure and the kind of the force, and when the pressure is released between these two plates moving against each other, we're actually going to get a lot of what are called fold mountains, when the rock bends backwards to fold and folds over where the two plates are meeting from that pressure. Sorry about the sound outside. So, how do we write this question? How do we write this answer? I'm just going to kind of plan it out for you a little bit here. But step one would be to talk about the movement of the plates. So what direction are they moving in? What type of plates are involved? And what's moving those plates? So the movement of the convection currents underneath the two pieces of rock here are moving the plates toward each other, and that is causing them to collide. Okay. Now the second thing that we can mention here is that after the plates meet, we're going to have this process of subduction. So that's the second thing that you're going to describe. You're going to explain that this subduction process is caused by the fact that the oceanic crust is denser, is not as thick as the lighter continental crust, but it's denser, it's heavier, it's older, and that's the reason why. And that's going to go underneath the continental crust here, and eventually melt. So step 3 is going to be our process of melting rock because of the magma, because of the intense heat and in the mantle. Okay, so you're going to put that into a sentence for me, or a couple of sentences explaining that that will push that through the rock. Step 4 is going to be the formation of the magma chamber. Okay, so the magma chamber finding itself deep within the crust of the rock. It's going to, over time, it's going to force magma through the vent. Magma will rise through the main vent, and sometimes it's going to go through a side vent. Just draw that very quickly over here, that sometimes it'll find it difficult if there's a blockage here to make its way out through the top of the volcano or through the crater. So instead it'll force itself a new path, and that will lead to the formation of a secondary cone. Don't have to, this is just a little bit of extra information for you. You can try and fit it in if you'd like, but we've got our secondary cone, and that's why that's being formed on the slope of the volcano rather than at the crater at the top. It's our crater here. And then step 6 can be that as this process repeats, we're going to see more and more volcanoes form in the shape of a volcanic arc, which is going to basically be all along the plate boundary, and the volcanoes will get bigger and bigger the more eruptions that happen. So you can tell me what kind of volcanic arc being formed, which is just again, if you imagine that this is your oceanic plate here, this is plate 1, this is plate 2, and we're going to have volcanoes all along here. Okay, that's going to be our volcanic arc, and eventually as the plate moves further and further, they will eventually find themselves in the middle of the plate and become extinct. That's just a little bit of extra information for you, but we're going to have the formation of a volcanic arc. We're going to have repeated volcanic eruptions, and the pressure building up is going to create more and more earthquakes. It creates deep focus earthquakes, very strong earthquakes. Okay, so good luck with that task. It's just under 10 minutes the video, and you will submit that to me on Google Classroom, and if I ask you to fix anything, you can potentially earn yourself some more positives by being very dedicated students and responding to your feedback. Good luck.